Oh boy.
Oh boy. Oh boy.
Oh boy.
Oh boy.
Hi.
Hi.
How are you?
I'm good. How are you?
It is a new year.
It is. It's been a while.
All this code that we have been writing about incrementing a year, and then it actually happened.
Yeah.
And it wasn't our code.
And nothing really has changed.
No.
It's just new year, new same stream.
It's been a while.
Yeah, I think it's almost been more than a month.
Yeah, I think so.
Yeah, we had some travel, some vacation time,
Busy.
sickness.
Busy.
And then we're good now. We're back.
Yes. Good to be back.
Yeah. Good. What are we gonna do today?
So I think a nice idea is, so we have 3 episodes left in the plan. So it's this episode and then 2 more. So it'll be this episode and then next week and the week after. And I think it's good to do one as a refresher episode. It won't be that long, and we'll also cover some of the stuff that we mentioned in the last episode about the bugs and some other stuff that people did.
We had some people that did some bugs.
People did, well, they fixed the bugs. We did the bugs.
We did the bugs. They fixed them. We'll get into that in a second.
Exactly. So it's good to refresh, get back into it, and then we can continue on.
Yeah, well, I hope everybody else has had a good New Year so far. A nice little break, but I feel like I've gotten dumb, and I want to get smart again.
Let's get smart.
We'll get smart.
Smarter.
Are we ready? That's smart. Yeah. No. No, we're just gonna go to you.
Let's go to me. Okay. So here we are again after the vacation. In this episode, we're going to do a bit of recap. There's an empty slide here. I'm sorry. The game is close to be complete, and there's only a handful of episodes left, like I mentioned. But after a vacation like this, it's good to get an overview. So enough blabber. Let's get to it. What are you smiling for? Well, what's all that smiling about?
I don't know. There's no way you forgot.
I didn't forget.
Okay.
Hi, space, G-A-B.
Oh my god, you are the worst.
Hi, Gabe. Who's he? Hi, space, G-A-B-E. There you go. Hi, Gabe.
If you didn't catch that first letter of each sentence, I was sitting here, I was like, he's probably just going to put it in somewhere randomly and catch me off guard.
No, sir. No, sir.
Hi.
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 That's good. That was a good one. Okay, so let's get to it. So, for our quick refresher, in the beginning, we talked about that programming is 3 concepts, 3 things. And then in an episode after that, we talked about it's actually 4 concepts, but one of them is kind of hidden. Or one of them is about hiding and is kind of hidden. So the 4 concepts are variables, conditions, functions, and abstractions. So let's go over each one of those. So variables. It's a way to store numbers in memory. It's where we would put data, basically. That is where the data is. If anybody asking like, oh, how does the code keep all the data? It is in a variable of some sorts. It's always there. And in the case we have over here, we have an integer called episodes, which then the variable's name is called episodes, and the variable's type is an integer, which means that we store numbers. And another way to do this, and in this case, what number is this one storing?
0? Or it's not storing anything yet?
It's not storing anything yet. Yeah, that is correct. We haven't put any value in that variable. And here in this case...
Now it's 8.
Yeah. So we explicitly... And we're doing 2 things here. Like here, this line is doing one thing. And the one thing is, it is creating a variable called episodes of type int. It's not doing anything else. And in this case, it's doing 2 things. It's creating a variable called episodes of the type integer, and it is putting 8 into that variable. So this is actually 2 things. And in some languages, you have to do these separate. In C, or in a strict variation of C, you have to say int episode semicolon, and then afterwards you have to say episodes equal 8. You can't do both at the same time. Declaration and initialization, exactly. And here, we are referencing a variable called episodes and then putting 9 into it. So if we think of the first line, the value after the first line has done executing, after the semicolon there, the value in episodes is 8. Then it goes down to the next one. And after it has done running, the value is 9. Not during and not before. So it's only after. So, while this line is running, which isn't a long time, but while it's running, the value is still 8. It's not until after we've done this, it is the value 9.
So if you had these two lines one after each other, the 8's basically obsolete.
Correct.
For the most part.
Yes.
Or not for the most part. It is obsolete.
It is obsolete.
Take the second one.
Yes, it will take the second one. And there are tools when you go into other languages that will catch this and say like,
no, don't do this.
Don't do this. You're being silly here.
Is that like, I mean, that's inefficient code, right? Because, or like,
technically it is. It isn't much. It's like very slightly, but this could be in one of your main loops.
Yeah, which means it's running that constantly.
Yeah.
Spending time doing something it doesn't need to.
Correct, yeah. But
inefficiency.
Inefficiency, yes. And we'll even go into that in a little bit.
Nice.
Yes. And because I mentioned the value of the variable afterwards isn't updated until after we have done the action. What that means is the value here is 8 until the second one has done running. Which then means, if I can use the mouse, after this line has done running, it is 8. So during this execution, it's still 8. So that means that this is 8. So it's 8 plus 1, and then we take that, which equals 9, and then we put the 9 in episodes. Or I could put it somewhere else. I can make another variable. That's also fine. And as Black Lotus also mentioned in chat, you can do episodes plus plus, or in this case, you can say episode plus equals 1, which is a shorthand for this. It's the same thing.
Just also, we didn't mention it before, but since this is a bit of a refresher episode, if you have questions in chat, I can act as the student that raises my hands and gets the professor's attention.
Yeah.
So if you have any questions, just let us know.
Yeah, and we're going to go slowly through this, and I can go back and forth. We're not going to code anything today, unless I have like a bright idea and want to do something live, which is always an idea. So we'll be in slides, and we'll have a good chat today. So yeah, doing plus equals is the same as this line before. So it is a shorthand. It's nice to have, and also you can do plus plus, which is the same thing as this. Okay. So if I have a variable called jelly beans, and I have, let's say 12 jelly beans, whatever that means, and I can say that the beans on the table are 8. I can then say beans on the table is plus equals to jelly beans. So I'm incrementing it by how many jelly beans there are.
What does plus equals mean again?
It is if I go back here. So here I had episodes is equal to episodes plus 1.
Yeah.
And if I do this, plus equals to is
episodes. It's the same thing.
It's the same thing.
Let's so make it short.
I'm incrementing it.
Okay.
I'm saying.
Okay, it's incrementing that.
Yeah, you can think of it as whatever the value is before, add this one also on top of it. So if I have 12 jelly beans, I have 8 beans on the table. If I say beans on the table plus equals the jelly beans, it's basically saying 8 plus 12. But since it is this is programming, and we need to store the value of whatever this action is in the variable, I have to say that we're going to increment and we can also store. And this is the same thing as saying beans on table is equal to beans on table plus jelly beans. So if you think of it that way. Or plus plus episodes. Yes, I don't know if processing the language supports plus plus, but that is a technical thing. You can do episodes plus plus or plus plus episodes. And that's a technical matter of what that means. So the next one. The next one was conditions. It's a way to ask a variable a question or variables. If the answer to the question is true, then the code inside of the condition runs. That's it. So it's a way to ask and run code under a certain condition. So if you go back to jelly beans, if we say that we have 12 jelly beans for some reason, and we ask the question, if jelly beans is bigger than 10, then we go into the code. That's it. And what this is doing is this code here, this bit within the parentheses, is run first. That's the first thing that's run. The if isn't actually done, and whatever is happening within the curly braces isn't done. It first evaluates this thing here. So jelly beans bigger than 10 is true. And we covered this in previous episode. This first turns into either a true or a false statement, and then, and only then, is the if executed. Because the if cannot know what this is. So that's done separately, and that's also why this is in, you can think of it, this is why it's in a parentheses. Okay? And we can join together multiple questions in one. We can do that by asking if A and B is true, or we can ask if A or B is true. And we can keep joining these. We can make an infinite chain of questions. That is absolutely possible.
Never ending.
Never ending. That's just more up to how much complexity do you want to work with. And in some cases, it's nice to split them down into multiple questions, just because it would make the code a little bit more readable. Because you can imagine a page of like if A and B and C and D. So it's kind of a tricky thing. There's also a thing that is in many languages. So if we would ask the question if A and B, I think I have an example here. Yeah. So if jelly beans is bigger than 10 and, which is double ampersands, jelly beans is less than 20. So we're asking, we need jelly beans between 11 and 19 here. They have to be. If jelly beans are 9, the first one fails. If jelly beans are 21, the first one is true, but the second one fails.
Skip it.
Skip it. There's a thing in many languages where it's called a short circuit, where because both of them need to be true. So if the first one is false, there's no need to ask the second question. So what compilers do and many languages do is they don't. They don't even ask the second question. And what you can do, it's a trick, is you can say, if some easy question, and some expensive calculation. Maybe it's a call to a function and it's a very expensive function to call, but you do this one check before, and that will actually save you the computation, because if the first one is false, you don't even ask the second question. That's kind of handy as well.
Yeah, so it's making everything more efficient.
Mm-hmm.
You don't spend time running on
efficiency.
Bam.
Mm-hmm. So we can then also say an or, which is the two pipes. If jelly beans is bigger than 10, or if jelly beans is less than 20. And there's a problem here. There's a problem with this thing. What is that?
Jelly beans is greater than 10 or less than 20.
So let's take an example. Let's say jelly beans is 12. So it's greater than 10. Cool. We can go into the if.
Yeah.
Let's say it's 19. That's also greater than 10. Yeah, we can go into the if. Let's say it's 9. 9 is not greater than 10.
Yeah. But
9 is less than 20.
Yeah.
So we go into the if.
Yeah.
Because either or has to be true. Let's say it is 21.
Then it's true, but the second one's false.
Yeah, but we need either one of them to be true.
Yeah. It's 21, so you still go into it.
Yeah. What number do I put that doesn't go in?
10? No, 20. No. What? No?
Is there a number I can put there where the if will not run? So we saw that 12 will go in. We saw that 19 will go in. We saw that 9 will go in. And we saw that 21 will go in.
Isn't it 10?
10 is less than 20, so it will go in.
Man, I have no idea.
All numbers will go in.
Yeah.
Mm-hmm.
Oh.
Yeah. all numbers will go in because
I was trying. What kind of trick question is that?
no, it's not a trick question. It's an actual question. Because all numbers are either bigger than 10 or less than 20.
Yeah.
What you will have to do is a statement like this. You would have to reverse both of them. If jelly beans is less than 10, or if jelly beans is greater than 20, and what you've then done is you've excluded everything except. So doing this and this, you kind of have to inverse it to get a similar effect. But then you've done the opposite effect. Okay. This is a very common error in coding. Yes, that is correct.
So if you go back one, so this is fine.
This is fine.
When you go here, every number is applicable because the two lines mean or.
The two lines mean or.
Okay.
So either one of these need to be true.
No.
In this case, both of them need to be true. Yeah. So this is more strict.
Yeah.
This is more loose, but
so how do you reverse it then? You just flip the
you flip these.
Okay.
So this will become less than, and this one will become greater than.
Okay.
But then you have done the opposite of this one.
Yeah.
Because this one wants a narrow range.
Yeah.
This one does not want the
this
narrow
one just
range.
wants to exclude those numbers.
Yes. If we would have flipped the greater than and less thans. Yes. And yes, this is a very common error because when I have an example like this, it can be kind of obvious to see like the fault. And if you get more used to looking at these kind of statements, you get used to the problem. But often in live situations, it's not that obvious that this is happening. Okay. So next one. Functions. So functions are a way for us to break code down into simple and isolated sections. And this helps a lot with reusability. Yes.
This is not C#.
No, it looks very similar to C# though.
We're using processing. If you type !tool in chat, you'll get the website.
This is actually a nice one. Black Lotus is saying, an easy way to explain this is by giving the door example. The two pipes are doors side by side, and you can choose which one of them you can enter. And the two ampersand, the doors are in succession, so you have to open both doors. That is what is very valuable in when you're learning programming is, if I explain something one way, you might be like, okay, I kind of get what you mean. But then sometimes it helps just explaining the same thing in another way. Like we were trying to get to some sort of core, and I explained it one way. I went from one direction and said, oh, this is this thing. And then you're like, okay, I kind of get it, but okay. And then if someone says something in another way, you're like, oh, I get it now.
Like referencing things to everyday behavior, because I imagine a lot of people go through doors.
A lot of people go through doors.
There's even into this office, we have to go through 2 doors. So that's an end.
That's an end. You have to go through both doors. You can't get in
unless you go through both doors.
You have to go through both doors, exactly. Yeah. And if you're going into a restaurant, the restaurant might have 2 ways to enter the restaurant. So you can just pick either one. Yeah, it's fine. So yeah, it is a great example. Another one is when we're dealing with, at least in C++, when we're dealing with multi-threading. What usually you have to do is you have 2 bits of code running at the same time. So you can think of it as 2 programs running with the same bit of memory. So they can't access the memory at the same time. And what you have to do is you have to lock the memory, use it, and then unlock it. And the example we used in college was as a bathroom stall. Like there's only one person that can go into the bathroom. They will close the door. They will do whatever they have to do. And then they will unlock the door and go out of the bathroom. So yeah, these kinds of visualizations, they do help a lot. So, but yeah, functions. It is a way for us to break code down into simple and isolated sections, and this helps with reusability. And we saw this a lot in the previous episodes where it was just nice to make a function where it was just, the function did one thing. It would ask a question, or it would calculate something, or it would change some values, because then we could just use the function somewhere. And we didn't have to care about how it did it. In the moment when we wrote the function, we were like, yes, this is important. This is what if this and what if that, and that's good. But then later on when we used the function, we didn't care. We were the users. So this is a kind of a contrived example, but this is often used as a beginning example of functions. This is a function that adds 2 numbers together. So it takes in 2 numbers from somewhere else. It adds them together, and then it returns them out.
So the variable is add. No, the variable is A and B.
Yes.
Why do we need to have add there next to the brackets?
Add is the name of the function.
Okay.
So when you create, this is you creating a function.
Okay.
Yes.
Yeah.
So you're here creating a function. You're saying this function is called add.
Yeah.
It returns an integer, and it takes in two numbers, A and B. And then here within the curly braces,
we want it to return the value of A plus B.
Yeah. And we don't always have to just straight return in functions, and I'll show you that later on. But we can have any code here. There's no limitations of what kind of code we can have in a function. So here's another one. I can ask a question, is A bigger? And then there we return a Boolean, because we're asking the true or false kind of question. Again, we take in two numbers. And we're just asking a question, is A bigger number? All right? And here's another one. And let's just say this is an add function that can only add small numbers for some reason. This is just a nice way to have a small bit of code. So what we can do is we still take in the A and B. And these things, A and B, they're named by us. They could be called Steve and Dave, whatever. It is for us to name them.
What are our dead spaceship names? Banana and
I
can't remember the other one.
Oh, I don't remember the second one. Yeah, so we can have Banana and Steve.
Steve.
Sure.
Oh, rip Steve now.
Rip Steve.
Someone needs to update the meme.
So in the function, we can ask a question. We can ask if A is bigger than 10 or if B is bigger than 10. Then we don't want to add. We just give back the number 0. Otherwise, we do whatever there is before. So this is to show that we can return in multiple points. Banana and kiwi. Nice. And here's another one to show, okay, I'm creating a strange add function. This one takes in 3 numbers. I call it A, B, and C. And I first create another variable. So here you can see I can still create a variable within the function. And I call it check because I want to check something. And that is the result of A and B. I ask the question, is check greater than 10? If it is, we're good enough. Maybe the idea is that we want to add numbers together, but as soon as 2 of them are greater than 10, we're done. So that's kind of the logic here. So if check is greater than 10, we're good. Just return the check. Otherwise, we add the C to it and then return it. Yes.
But here, so where does the value of... So, okay, sorry. So check is A plus B.
Check is A plus B.
And if we want it, and then we ask it the question, if check is greater than 10, then we return the value of check. And if it's not greater than 10, then it just returns the value of A plus B plus C.
Yes.
Okay.
Which, yeah, because check is A plus B. So we're in fact returning A plus B plus C. Basically.
Yeah. Mm-hmm. But if it's greater than 10, then we just return
check.
A plus B, basically.
A plus B, basically, yes. Yeah. But the value of A plus B is still being stored in check.
Yeah.
So check is its own independent variable. It doesn't have memory of A plus B.
Yeah.
It just has the value of what happened when A plus B were added together. So in this sense,
and somewhere else A and B will have values.
Yeah, A and B are alive in this function.
Yeah.
And for someone who is calling the function, A and B are also there.
Yeah.
Yeah. Or they're not called A and B there in that sense. They might be just called something else. But for us, we don't know where these values are coming from, and we don't know what they mean. We just needed to do some sort of action. So then that means that anybody can use our function to do their work. We don't care where they're being used. It's like you make a hammer, you don't care where the hammer is being used. It's still a hammer.
I mean, I wouldn't want someone to kill someone with
Correct.
a hammer.
Yeah. And that would be nice to have like a if check.
If person wants to kill, do not give hammer.
Do not give hammer. But the issue there is giving the hammer is not a part of the hammer. It's a part of some other thing. So
damn it.
Yeah, there's problems here. Functions are needed to remove spaghetti, Black Lotus says. Yes, they're very helpful in isolating areas of complexity. That's very good. Yeah, int smoothie, add strains, banana, kiwi, strawberry. There you go. There we go.
But how many bananas?
So here we can use the function. Let's just say that somewhere in the code we had written the function. It's set up and it's great. And we send in the numbers 2, 3, and 4. And just like with the addition, where we could say a plus b or 2 plus 3, this thing here, add strange, will give us a number. The function does its work, but in the end, it just turns into a number. You can see here that in this case, we're getting a plus b, and in this case, we're getting a plus b plus c. All of those are just numbers. So calling the function gives us a number, but only after the function has stopped running. Too many independent functions also create spaghetti. That is also true. It is a, there's no silver bullet here.
Spaghetti code.
Spaghetti. And here to also see...
Where does the phrase spaghetti code come from?
It's the idea that, because like here, I'm calling add strange, and then I take the result, and I take result and put that into add, and that does something, and then you can think of this as a line that's being traced through the code. We have 2, 3, and 4 that are going into add strange, and then there's a line going into result, and then result goes into add, and add goes into sum. So there's like a line tracing through. And the idea with spaghetti code is, if you imagine a bowl of spaghetti, it's just a tangled mess.
Yeah.
And it's not easy to see what is going where and how. So that's the idea of spaghetti code. So here you can see that even though I sent in the actual numbers 2, 3, and 4 into add strange, the result is a number. And I can take that, because that is a number, just like 2, 3, and 4, and I can send that into add, because add just wants numbers. It doesn't care if it's an actual number like this, or a variable that represents a number. It doesn't care. All right? So, and then later on we learned about classes. And a class is a simple way to group together variables and functions. That's it.
Bam.
Bam.
Class is dismissed.
Class dismissed.
No, it's not. Stay seated.
Please stay. Don't go. It allows us to model concepts directly in code. So what we did is we created a box in our code. And for us, we could imagine that idea. A box has a place and a box has a size. And that is, like I have boxes here on the screen next to me. Like a box is a very, it is a concept that we know very well, basically. Classes are the silver bullet for the spaghetti functions of spaghetti of functions. Yeah, they're kind of. There was a big revolt, or not revolt, big movement in the 90s that everything had to be classes and everything had to be object oriented, and then people found out that there's also problems with that, because then you just create a spaghetti of classes. Yeah. Classes are not objects. Yeah. A class models an object, but a variable of a class is an object. That's how it is. So you can think of class as the blueprint.
Yeah.
How to make a thing. But once you've actually created a variable that is storing the class, that is an object of it. So you can think of an idea of a chair. You can draw a blueprint of a chair. But then when you see an actual chair, that is the object. But you can still make more chairs, and you use the class to make more. So for us, the box was the blueprint, but the enemies on the screen were the objects of the type box. Yes.
Yes.
Yes. First year at university, professor says, create as many classes as possible. 5 months later, classes are bad, so don't use them that frequently. That is correct. Yes.
Is that similar? I mean, I guess maybe that's following the same logic as you taught me in the beginning, which is practices that aren't great, but better to understand concepts in a certain way.
Yeah. What I've done early in the lectures, and if you go back to the early videos, is we've only introduced like questions or functions or classes or whatever when we had a problem. Like we looked at the code and we said, this is a mess. We can't work here. And then in the next episode, I introduced a thing that solved our problem. Because it's important for us to look at the code and see there's a problem right here. An early one was, it's tricky to have many enemies because you have to just create a lot of them. If you wanted to have 1,000 enemies, you'd have to have 1,000 variables. And then later on we said, hey, here are arrays, which are collections of variables. And speaking of that, aha, you see that? I'm
good transitions.
Good transitions. So
nice.
An array allows us to create many variables of the same type together. And that is those 2 points are the big points. It's many variables of the same type, and they are together. They are just one after another. With a class, you could group together whatever variable you want. You could put in a number, a boolean, another class. It didn't matter.
That's how we created our screen full of boxes.
That is correct. We had arrays to create so many enemies. Over 9,000.
And then we beat them up.
Yeah.
We did.
We did. And usually what what this is called is a collection of elements. It's usually what the people refer this to. So an element isn't one item in the array, and then you have a collection of them. Okay. So here's an example. So before we would create a variable called something. It would be an integer variable. When we have the brackets, the square brackets, that is to denote that this is an array. And then you say, so again, this is doing two things. First, we are creating the variable int brackets numbers. And the second thing is we're creating 20 of those numbers. And then I can access the numbers just like any variable. There's no difference here. So I say...
It always starts at 0.
Array starts at 0.
Someone's asking in chat, is processing more based on C or Java?
The underlying, for processing as the application itself is based on Java. The one we have been using is using JavaScript, but the syntax is its own syntax. Yeah.
But it transitions well into C, for example.
Yeah. Processing is a very good language to help with C, Java, C#, C++, because it's very similar to those languages. Yeah.
Conquer everything.
Yeah. Okay. And then the next thing. So we had a problem with arrays, which was, cool, we have all these variables. We could create 20 variables in one fell swoop. But if we would have to do something to every one of them, we would still have to do 20 lines of things.
Noah in chat's asking, what's the difference between int brackets numbers and int numbers bracket?
It is a language difference.
Let's go. Arrays.
Arrays. It was a way to create collection of variables. There was a question before we went out. The difference between saying int brackets numbers and int numbers and bracket. That is a language difference. Some languages want the brackets after the variable. Some languages want the brackets after here. It's just a language difference. Otherwise, there is no difference in that. Or if it was meaning if it's the difference here, it's the only way we can actually refer to the number. So, and we had a problem with arrays. And the problem with arrays was, even though we could create 20 numbers in a row, if we wanted to change all of them, we still had to go through them one by one, and that wasn't great. So that's
myself in the face.
Yeah. So the solution to that is loops, and the idea with a loop is to run a certain bit of code again and again. That's it. So think of it as an if statement that can just keep running, or a function that we can just keep calling again and again. So it uses conditions to know when to stop executing. So the basic one is almost like an if. So you have a while loop, and you can say while I is less than 0, and then you just have some code. Usually you would want that code to change I, because if it doesn't change I, then the loop is going to go on forever. And what you can also do is you can say while true. That means that the code will run forever, because that's always true. And also, if, let's say, I is not less than 10. Let's say that I is greater than 10. We won't even go into the loop. Because here, I has to be less than 10 for the loop even to run once. So just like with conditions, we will come down here.
It's basically it's just an if question.
Yeah, it is an if question, but it will just go down to the brace and then go back up and ask the question again. That is the only difference.
And as soon as we pass Well, yeah, as soon as we hit 10, it stops.
Yeah, it stops. Which is why we would need to change the number, because if the number doesn't change, the question doesn't change, which is the same thing as just running forever.
Yeah.
So, and then there's another type of a loop, which is the for loop. And we saw in an early episode that this is basically like, here we are creating a variable, and this only happens once. Here we are asking the question. It happens in the same way as the while loop. And here we are incrementing the number, and it happens at the end. So the int I0 is done once, and it's done before we go into the loop. The question is being asked every time before we go into the loop, just like with the while loop. And the I++ happens at the end. So here, I is 0. We will ask the question, is I less than 10? Yep, I is less than 10. We will go into the code. We won't do the third thing. We will do whatever the code is. And then at the end of the curly brace, we will increment the number by 1. We will go back up. We won't do this first part because it only happens once and only in the beginning. We will ask the question, is 1 less than 10? Yes, it is. We will go in, do the thing, increment the number, go back up, is 2 less than 10, etc. So we will continue that. This is nice. And these numbers here, the 0 and 10, can be from variables because they're just numbers like anything else. But it's nice that if we would have a collection, like an array, that we can just go through the array. We don't want to modify anything. We just want to do something with each element. So in processing and in many languages, there's usually a loop like this. So instead of semicolons, we just have a colon. So we say for int number, and usually what we say here is for int number in numbers. And then it will just loop through. So this is a much nicer way of writing. You don't have to remember all of this stuff. And this thing here, numbers, this is just an array, nothing else. For each isn't available in every language. Yeah. But usually many languages have something like it. Yeah. So that is the recap. Let's talk a little bit about last episode.
Yeah.
So in the last episode, we had a screen full of bullets.
We did,
literally.
We had enemies. We had a screen full of enemies to start with.
Yeah, and we tried to fill it with bullets.
Yeah.
Yeah, there we go.
Then there were no more enemies.
No more enemies. But we had a bug, which we sent out a challenge to, that can somebody fix the bug? And we also had a challenge, can somebody design new kinds of guns? Because the gun we had was just random bullets in all directions, which is a fun gun, isn't very balanced. Not very.
Well, I mean, balanced in a good way or a bad way.
Well, if it's a single-player game, it's probably fine. Yeah. If it's a multiplayer, it may be a little crazy.
Maybe. You just gotta get really lucky.
Yeah. So we put forth the 2 challenges. It's the fix of the collision bug. The collision bug was, and we even have video. So those, I will mention in a little bit. Those who fixed it made videos.
Nice.
So let's see how well this looks like. So here is before.
Can you move it over to the center just so it's away from our webcams?
I'll do it like this.
In between us. It's a video sandwich.
Video sandwich. So what's happening is, if the bullet is small enough, it will just go through the enemy. Yeah. But in there, you can saw in the last one, it didn't go through.
Because it hits one of the corners.
Hits one of the corners. And that was the problem.
Yes.
And not only was that fixed, so we have a fix for it here. So now when someone goes in and shoots, boop.
Got him.
So that's fixed.
I love the lining up the shots.
Very. It's a mark of a good developer, at making absolute sure that we're doing the right thing. So it was to fix the collision bug, and so I thought it was nice to be like, let's have a regular programming task, or like a fixing a bug, and also like a creative task to make a new type of gun. So the collision bug. So Kokumo on Discord not only has a solution, but optimized the code as well.
Oh snap.
Because, so this is the code he wrote. I don't even know if it's a he or she. This is the code Kokumo wrote.
Yes.
Let's be more specific. I made pretty, and the comments are from the code. It was written using the processing desktop app. There's also a desktop app. The language is slightly different in the syntax. So I'm not still sure if the syntax is right for us. I try to fix it, but it should still be readable. So this is the question or the function that we wrote, which was, is box inside boxes? And the bug was there. So what we're doing is, this is the loop that we talked about before. We have a collection of boxes. We would like to ask if our box is inside any of these boxes. If the box is actually null, we don't want to do anything with the box. And I'm going to show the next slide because the code is a bit long. So I'm gonna scroll up basically. So this is the function, are they too far apart? And here it is up here. So we should still see it. I'll go into that one in a bit. So what Kokumo did, and is the bug, is this. So Kokumo even made a picture explaining what's going on. Because what's going on is we're only checking the points, the corners. And if an object is small enough, it can go in between them. Like absolutely perfectly.
I'd be real mad if that was the case. In like a shooter, you hit someone in the head.
Exactly.
You just hit them in that one spot.
And I love, like, because we had also a function, is point inside box. Because is box inside box is just a lot of, is point inside box questions. And Kokumo put the dot and the box to represent that you put in a representation of a dot and a representation of a box. It was so good. I really, really loved this. I was laughing out loud when I saw this posted on Discord. Because this is like the abstract representation that we are putting into the arguments of the function. Even though they're just numbers, in our minds, it is a point and a box that we send in, which is amazing. This is great. So, and the problem is, we check one of the boxes, not both of the boxes. Because, like here, this box here, the big one, is never inside the small one. The small one is inside the big one. So Kokumo asked the question, is box inside box? Like we had before, there's no difference there. And if that's true, then that's fine. That's a collision, we can just exit out. But if that's not true, Kokumo swapped the arguments. So it's basically asking the other box and actually creating a new box on the fly, which is the other box to check it with. So it's basically asking the question twice. So no collision for now, but is our A box smaller than the current box? So if the box is smaller, so if the width of our box is greater than, if the width of the box coming in is greater than the box width of our box, or if the height is greater, so if any of the dimensions is bigger and there wasn't a collision, we swap the arguments. So instead of sending in box over here, we use box X, box Y, box width, box height, and make a new box, which is us. So it's flipping around the arguments. And if there's a collision here, then there's a collision. Otherwise, we go away. It's a false. So that is the solution. That is a solution to do this. You can flip around the arguments. There's another solution which is a little bit more tricky to do, which is to check the lines. It can be more expensive, but this is a fine solution. And to optimize, Kokumo wrote, are they too far apart? So that is a pretty cool function, because what Kokumo is doing basically is, if a size of a box, like we have a box of some sorts, let's say this is the box over here, we know the height and the width, and we can calculate the distance between one box and another box. And if the distance is further than the width of the both boxes combined, there's no point in checking it. So I have something here. I have my phone and I have two boxes. The width.
Want to go big webcam?
Big webcam. We can do that. Here we go. So I have the phone here. You do it like this. And I have a remote over here. The distance between these two objects, between the center of this remote and the center of the phone case over here, is more than the width of these two objects combined, right? This object's width, let's say that this is 1 and this is a half, and the distance between them seems like 2.5, right? And that is what's happening here in this code. So we get the total width, which is the width of one box plus the width of the second box, and also the height. Multiply the x and the y to remove the sign because they might be swapped, so we don't want to have a minus number. So we multiply these together and ask if the difference between those two is greater than the difference between the x and y is greater than the width. So when we go here, we are looping through all the boxes. The first thing Kokumo asks is, are they too far apart? If they're too far apart, we don't even have to do any of this. But only when they are getting a bit too close together, we can do this. So this saves a lot of checks, because even though this looks like a bit of code, this isn't that much. And this actually can be executed pretty quickly.
So this basically removes, if I shoot a bullet at you, it's not even going to check if it's going to collide until it's close enough to even be relevant.
Yes. So you shot a bullet. The bullet size is a certain size. I'm of a certain size. And the bullet just went way over my head. It doesn't even need to check it. It can totally ignore everything that's going on. And that then means...
What does that mean in terms of performance?
It can be night and day. If it is optimized correctly enough, it can be absolutely night and day. And then there's another optimization that is possible if you can add more code to it. If you can know what quadrant, if you take the game screen and you break it down into little spaces like grids, and you know in what grid each item is, and you're looping through, hey, am I colliding with something? Am I colliding with something? Then you would only get here in this argument the boxes that are close enough to you in a similar grid. So you are in some point in the center of the grid, and you would ask the question, am I colliding with something? You would only check the values around you, which then means that you could have a game world that is very big, because the collision checks will never ever check anything that is further away. It won't even loop through them. So not only do we have an optimization here, we could have an optimization where we don't even loop through all the items. But here, if we would have 5,000 items on the screen, we would still loop through 5,000 items. So this can be night and day. Nice. Okay. So that was Kokumo. Thank you very much, and we will be in contact.
Yes.
Yes.
You have a prize.
Mm-hmm. So the next thing, fun thing, Art of Sound on Discord. Not only made one gun.
Oh, snap.
He made 4 guns.
Oh, snap. What's better than 1 gun?
4 guns. So let us look at the video for that. So the first one was kind of a spray. That was a fun one. Then we have a shotgun type.
Oh my god.
And then I think the last one was like a... Yeah, it was like a sniper laser thing. And then this.
What?
It's like a sign...
Snake bullet.
Snake bullet. We can see that again. Let me see. Spray that again. So we had a spray, kind of like a bad machine gun, right? Yeah. Then we had a classic shotgun.
It's like a SMG basically.
Yeah.
Really, like inaccurate.
Yeah, it's good. And then we had like a sniper straight on, and then we had the bzz bzz.
The bzz bzz.
Yeah.
I guess like maybe that is like for some reason that made me think of the Ghostbusters.
Oh yeah. It's like a stream.
Yeah,
that is correct.
It's a stream.
It's very good.
I don't remember what it's called.
So we'll also be in contact with Art of Sound.
Those were awesome.
Art of Sound didn't post all the code, but it posted a bit of the code, and we can go over a little bit of what's going on. And also, it's not much code you have to write a gun. So here is the shotgun. So when the key B is pressed, and so what Art of Sound did was, here's a thing called time. And what time in their project...
Oh, wait, hold on. We can have all those guns and just bind them to different buttons?
Yes. Yes.
Oh, we're going to make the best game ever.
Yeah. And my idea is that I kind of want to have all these guns in the game. So before we start on the next episodes after this, I'm going to try to put all the guns in some way. So then you can also play with that.
Oh, yeah.
Don't cross the stream, exactly. So for time, what Art of Sound is doing is basically counting the frames. It's just time is just +1 per frame. So you can only shoot the shotgun after 30 frames has passed. So it's and there's also a show which I wasn't exactly clear on, but anyway, this works fine. So it's 14 pellets. So here we just have a classic loop. I is 0, I is less than 14, I++. It's just looping through 14 times. So it's creating 14 bullets from the spaceship's point of view. Spaceship X 32, spaceship Y is 14, and the size of it is 4 and 4. But here is the main logic. The horizontal and vertical speed is random. And the horizontal spread, the horizontal speed is 7 to 10. So some of the bullets are faster than the other ones. And the vertical spread is from -1 to 1. So it's a little bit of a spread going on here.
So they come out in like a cone shape.
Yeah, a little bit of a cone. And you can just mess with these numbers, and that's kind of the idea of gun balancing. It's just playing with those numbers.
How do you even make the proton stream then?
You'll see that in a bit. I have the code for that one. So this is for bullet count. I don't know what that one was for, and then just reset the time. Okay. Yeah, this is the proton stream. Yeah, I had the code for that one. So again, you hit V. If time is greater than 2, which means there's a little stagger in the shots.
It's called the saw gun.
Saw gun, yeah.
Saw gun.
You create the bullet from the spaceship, but here it's something called the Y transition.
Which means, I guess, the movement along the Y-axis.
So the X-axis is the same, but the Y-axis is the ship's Y-axis plus 16 plus some number here, some Y transition thing. And the size is always the same. The speed is always the same, horizontal 8. Fine. Doing some bullet count, doing some time resets, those are fine. But
so
here
it's asking if Y.
So we already have the variable Y transition. So we're updating it. Y transition is Y transition plus YY, which is some variable there. And if the Y transition is 15, or if it's -15, we will flip around the numbers. So this is by how much should you go up. So when you shoot the gun the first time, and we can just maybe play the video a little bit at the end there, here. So when you shoot the gun the first time, the Y transition, if I can I maneuver this a little bit here, the variable Y transition which you have here, it might be some number. Let's say it's 0 in the beginning. And then what the loop does is that it says Y transition is Y transition plus YY, which is, let's say it's the number 3. So it's 0, then it's the number 3. Okay, cool. Then we'll go up 3 pixels. It's not greater, it's not 15, and it's not less than 15. Cool.
So just keep going.
We won't do anything here. We go back up, we make a new gun, and make a new bullet with the Y transition as 3. So it's a little.
Basically, as soon as it hits 15 or -15,
it will reverse
it and goes down.
Yeah.
And then hits the other one.
And what it's doing, it's not reversing Y transition. It's reversing this thing here, which is by how much of up or down should you change. It's pretty clever. So what you can also do with this code is you can mess with the horizontal, so it's a little tighter together. Change the YY, which means that the up and down will be tighter together, and you can actually make like almost a sine wave of bullets there.
That's really cool.
Mm-hmm. So it's pretty well done. Yeah, that's it. That is it, sir. So
also contact
Art of Sound.
Yes, Art of Sound, because those were awesome.
Those were awesome. Is it? And make your own guns as well. Have fun with it. And You can. The cool thing is you can bind it to your own key, so you don't have to override all the keys, and you can just play with it.
So it's just like also like I'm just imagining like a game. You're running through a level. You pick up different guns.
Mm-hmm.
I've been playing a lot of Doom lately.
Doom is good.
Just running around picking up different guns, and they all act differently.
Yeah.
Some shotguns. There's a kind of like a little stream gun, but it's not really a mini gun.
Yeah, that's it.
Perfect.
Yes. Just that we're almost done, so you can.
If anybody else has any other questions,
if there's any questions here, otherwise, so there will be an episode next week
and the week after that.
The idea with the episode next week is to introduce some sort of gameplay loop into it, where we can die, but if we kill all the enemies, we will have like a win screen. So. That is kind of a tricky thing to do, or it's more tricky than people think. Basically, that's the idea. And then we will be done with the game, basically. So the idea is that next week, when we add in the gameplay loop, that is it for the game itself. And then we have an episode after that, which is a little surprise I want to have. And that's also kind of a way to summarize up.
I don't even know what's happening in that episode.
Nope.
Pretty sure it'll be a surprise for me too.
I haven't told him what it is.
Well, snap. But otherwise, yeah, I mean, we'll talk about what the end of season 1 means, but I think we're pretty confident in saying this has been fun.
This has been very fun.
I don't want to like sound like we're signing it off because we still have 2 more episodes left.
Yeah, we have 2 more episodes.
But we have more planned in the future.
There's always fun stuff to do.
Thanks everybody for hanging out today.
Yeah, thank you.
We'll be back next week. If I just look at the calendar real quick. So next week is the 1st of February.
Yeah, 1st of February and the 8th of February.
Yes. So if you want to come wrap up this fun adventure, get some smarts, come hang out.
Get some of that
same
knowledge.
Time next week.
Yeah. So
thank you, everyone.
Thank you very much for joining. Bye.
Bye.